for what values of x. So this is an example actually. For what values of x can we replace sin x by x minus x cubed by 3 factorial with an error of magnitude no greater than 3 into 10 raised to power minus 4. Okay, so we know that our sin x has a series that is something x minus x cubed by 3 factorial plus x5 by 5 factorial minus x7 by 7 factorial plus so on up to infinity. So can you see this is in an alternating series?
Yes, sir.
Yes, sir.
So we've done that other part in the alternating series as well.
Yes,
Right?
sir.
Yes, sir.
So how we actually do it? So we were like, let's say the part 1 by alternating estimation theorem. So what happens if I talk about alternating estimation theorem? That means this our first unused term is error, right?
Yes, sir.
We have proved that
Yes,
first
sir.
unused. So according to that, this error should not be greater than this amount. That means 3 into 10 raised to power 4. So what does that actually mean? That means if you take the mod of first unused term, this error should not be greater than this. That means this error should be less than this, right? That's what we want. So we want to find out the values of x for which the error should be less than this. So from here, we can write it as x raised to power 5 upon 120 into 3, is less than 3 into 10 raised to power minus 4. So mod of x raised to power 5 is less than 360 into 10 raised to power minus 4. And let's say if I take that 5 to here, 1 by 5. So that means if you calculate it, this becomes this. Right? So that means if you take the values of x, from minus 0.54 to 0.514, then the error, then sin x can be approximately written as x minus x cubed by 3 in such a way that error of actual terms and sin x will not be more than 3 into 10 raised to power minus 4. So are you getting this? Are you getting this? है ना? So अच्छा, अब ऑल्टरनेटिंग एस्टिमेशन का और फायदा क्या है? अभी हमने रिमाइंडर एस्टिमेशन थ्योरम नहीं करी है, हम इस पे रिमाइंडर एस्टिमेशन थ्योरम लगाएंगे जो हमने कल करी थी, रिमाइंडर एस्टिमेशन थ्योरम, राइट? तो कैन यू टेल मी वन मोर थिंग कि ये है हमारी ऑल्टरनेटिंग सीरीज एस्टिमेशन थ्योरम, इसका एक फायदा है, वो फायदा क्या है? कैन यू टेल मी एनीथिंग? यस, कैन एनीबडी? Huh? We can tell that whether this is going to be underestimate or overestimate. ये हमने बोला था, तो वो ये underestimate होगा या overestimate होगा इस केस में? Is positive. Therefore, remainder theorem, I'll write sin x as x minus x cubed by 3 factorial plus r3. Is it fine or not?
Sir, yes. Sir, please resume from the previous page.
Yeah.
End of the previous page.
Yes. So end was there. I was saying that the sin x is an underestimate. Why? Because your first unused term is positive. So yes. So at that point I just concluded. Okay. So I'm taking this sum by I'll solve this sum by remainder estimation theorem. See, first of all, I've done it by alternating estimation theorem, which we have done in our previous lectures, and in just previous lecture we have done the remainder estimation theorem. Now I'll solve the same sum by using the remainder estimation. Is it okay? Right?
Yes, sir.
Yes, sir.
Is it fine? So that's how we write it. Why? Because let's say you go to the the previous page where I solved that thing. Sin x was this, right? And then I claimed that it has to be 2k plus 1 over here if I taking the if I write it as in a 2k plus 1 format. Okay, so that same 2k plus 1 will be there. Okay, that's what I have explained in the last lecture.
Yes.
Right?
Yes,
So
sir.
that's why I'm writing it in this way. Okay, so are you with me on this?
Yes,
Yes,
sir.
sir.
So now if you see this, your R3 mod would be less than equal to mRn plus 1 fn plus 1 c upon n plus 1 factorial. That's what we have done, right? Let me call it as Rn, right? That is our formula.
Yes,
Okay. So if you take it for R3, then it will become what? M is 1 here, as I've explained. R is 1 here. So 1 times Fn ka mod. That would be, of course, I should write it. No, it's fine. So Fn ka mod is always less than 1. Why? Because you have a sine or cos function in the derivative. So that would also be 1.
I
And
think
rest,
we
you will
Okay,
have
it's working.
x raised to power 4 upon n plus 1 factorial. Yeah. Is it okay?
Yes.
Sorry, I should replace it by here also 3 plus 1, 4 factorial. Which would be mod x4 by 24. Why? So we say that which is not good. Which is not good. And that not good factor, हम देखो ये यहाँ हमारे पास आ रहा है x5, है ना? और यहाँ आ रहा है x4. ऐसा क्यों? So that is the difference which I want to explain over here. Okay. So if we now, I'm telling this, but if we rewrite x minus x cube by 3 factorial as 0 plus x plus 0 times x square plus minus 1 times x cube by 3 factorial, then you will come to know that plus 0 times x4 factorial, right? Then you come to know that this is the Taylor polynomial of order 4 and order 3 as well. तो तुम इसे ऑर्डर 3 का भी बोल सकते हो, ऑर्डर 4 का भी बोल सकते हो, ऑर्डर 5 का नहीं बोल सकते क्योंकि 5 में नॉन जीरो टर्म आ जाएगी, राइट? सो दैट इज द इंपॉर्टेंट पॉइंट. So therefore this is a Taylor's polynomial of order 3 and as well as of order 4, right? So then we can actually write it as sin x is equal to x minus x cube by 3 factorial plus 0 times x4, and then r4 will come into the picture rather than saying r3. Now if you calculate r4 ka modulus, then it will be less than equal to mod x5 by 120. So you need to take care of that कि जहां जीरो आ रहा होगा तो तुम्हें बेटर एस्टिमेशन के लिए उसे इस तरह से एस्टिमेट करना पड़ेगा. So there is one problem with this remainder estimation thing, so which I have explained. So are you with me on this?
Yes, sir.
Yes,
Right?
sir.
Yes, sir.
Getting the point? Okay.
सर एक डाउट है इसमें.
हाँ जी,
तो
हाँ जी,
मतलब
बोलो.
बेसिकली हम इस क्वेश्चन से प्रूफ ये सिर्फ यही करना चाह रहे हैं कि टेलर पॉलिनोमियल होगा.
हाँ, ये टेलर पॉलिनोमियल, बेसिकली हम टेलर पॉलिनोमियल नहीं प्रूव करना चाह रहे हैं, हम ये प्रूव करना चाह रहे हैं कि यहाँ पे अगर फर्क क्या आता है ऑल्टरनेटिंग एस्टिमेशन में और उसमें. देखो अगर ऑल्टरनेटिंग एस्टिमेशन जाओगे, so if you go to alternate estimation doesn't depend upon the next term, actually it depends upon the first unused term, right?
Yes.
So
Yes,
it
sir.
gives you your estimation directly. So there is no such problem. But your remainder estimation theorem is something which depends upon the Taylor polynomial. And there are the ways where this is the scenario where you can have two Taylor polynomial of the same thing. Why? Because this zero comes into the picture. Okay.
Yes.
So when this zero comes into the picture, you can also write it as R3 and you can also write it as R4. So it's better to write it as R4 than by writing as R3. Okay, right? Are you getting my
Okay,
point?
sir.
So that
Yes, sir.
R4 will gives you a better estimation. That's what I'm saying. So sometimes it may happen just because it depends upon the remainder, and remainder is something which doesn't recognize that the previous Taylor polynomial was of order 3 or order 4. So that you need to check it manually. Okay, but the same problem is not with the case of alternating estimation theorem, because it is directly depending upon the first unused term, right? So it doesn't take care of the previous zeros or anything else. Is it okay?
Yes,
Okay,
sir.
sir. Yes,
So
sir.
that is the reason why I'm saying this. Okay, so let's say this question number 19. So now this is your exercise 8.10. Okay, so I'm taking few questions from exercise 8.10. So this is question number 19. So let's do it. So for what values of x, for appropriately what values of x, directly writing as for what values of x can you replace sin x by x minus x cubed by 6 with an error of magnitude no greater than 5 into 10 raised to power minus 4. So is it a similar kind of question? Right?
Yes, sir.
Yes, sir.
Is it a similar kind of question? Right?
Yes.
Okay. So this is something which we can do by alternating estimation theorem as well. So you don't need to, it is, it is not compulsory until unless if somebody is not asking you specifically, then you simply say it as by alternating estimation theorem. What would be your first unused term? x5
X power
by
5,
5 factorial.
5 factorial.
And that should be less than,
Yes, sir.
Yes, sir.
right? So can you do it? आगे
Yes,
तो
sir.
आसानी है ना, उसी तरह से ही करना है हमें, x की वैल्यूज निकालनी और कुछ नहीं है. ओके, फेयर इनफ.
Yes, sir.
ओके, अब देखो, अब क्वेश्चन आ गया है जो है cos x के लिए. थोड़ा सा चेंज है, बहुत ज्यादा नहीं है. So if cos x is replaced by 1 minus, if cos x is replaced by 1 minus x square by 2 and mod x is less than 0.5, what estimate can be made for error? What estimate can be made for error?
Yes,
Yes,
sir.
sir.
So what we have? We have mod x is less than 0.5, right? So if your mod x is less than 0.5, so what would be your error? See, so cos x is 1 minus x square by 2 factorial plus x4 by 4 factorial minus and so on up to infinity. So can you tell me, this is your first unused term, right?
Yes, sir.
Okay, so this is what? First unused term. Okay.
Yes, sir.
So अब error इससे आना है. Okay, so error will be always less than equal to what? mod x4 by 4 factorial. And what are the values which you are taking? You are taking the values to be less than 0.5. So kind of maximum value which you are taking, which you will take, of course वो achieve नहीं होगी, लेकिन ज़्यादा से ज़्यादा हमारे पास क्या है 0.5. तो error जो है वो 0.5 से बड़ा नहीं हो सकता. मतलब अगर हम 0.5 डालें तो उससे ज़्यादा, इससे ज़्यादा बड़ा नहीं हो सकता. ये जो amount मैंने लिखी है यहाँ पे. So that means this will come out to be 0.0026. So error will always less than equal to 0.0026. Are you getting this point?
Yes, sir.
पिछले क्वेश्चन में क्या था? See, there is a difference. In the last question, we were getting the values of x for which the error should be less than this. In this question, we have already the values. Now we are getting the magnitude of error. That error cannot be more than this. Okay? So the reverse question has been asked. Right?
Yes, sir.
समझ आ रही है ना ये चीज? थोड़ा ही फर्क है, कोई ज्यादा फर्क नहीं है. Are you getting the point?
Yes, sir.
Yes.
So the estimate root 1 plus x is equal to 1 plus x by 2 is used when x is small. Estimate the error. So the same question which we have done in just previous question which we have done, the same kind of nature is there. We are asked the same thing, that estimate the error part. Estimate the error when value of x is given to you, that your x cannot go beyond 0.01 mod x, right? So can anybody tell me that what is the series of this 1 plus x ka root? Do you know what is 1 plus x raised to power n, especially when your n is in a fraction or maybe negative?
1 plus x by 2.
1 plus nx plus n into n minus 1 by 2 factorial x square. Do you know this?
Yes, sir.
Yes, sir.
Yes, No, sir. sir.
Everybody, right? So
Yes,
that
sir.
is
Yes,
1
sir.
plus x by 2, and if you calculate it, it will become x square by 8 plus x cube by 16 and so on up to infinity, right? So again, your first unused term is what? Mark your first unused term.
X square minus x square by 8.
Yeah, but we always take the mod of that. Okay, so we don't care about that. So that is error which will be less than minus x square by 8. So that is x square by
Square by
8. But the maximum value of x, as x cannot go beyond this value, so that means your error cannot go beyond this value, right? So something I'll directly writing it 10 raised to power minus 5, right? So you'll conclude that your error will always less than 1.25 into 10 raised to power minus 5, right? Is it
So
fine?
can you please switch to the previous slide?
Yes, please.
Yes, sir. Thank you.
Okay. Okay. So can we do it? Can we do the next part?
Yes, sir.
Yes.
Right. Okay. So now see this. So I'll do 2 or 3 questions maybe. That's it. So let's come to the question number 23. Now what is that? The approximation Ex, which is equal to 1 plus x square by 2 factorial, is used when x is small. Use remainder estimation theorem. Use remainder estimation theorem right, to estimate the error when your x cannot go beyond 0.01. Right? Are you getting the statement? Is it fine?
Yes, sir.
So now you clearly think that your ex is this. So is it a polynomial? Is it a Taylor polynomial of 3 order 2? Right?
So,
So you know that in the representation of ex, you don't get any zeros, right? So there is no confusion that whether you want to write it R3 or R2. So you clearly know that it will be nothing but R2x. Fine?
Yes, sir.
Are you with me on this?
Yes, sir.
So there is no confusion. Okay. So now, see, what is your R2x? Tell me. Xn plus 1, right? Fn plus 1, n plus 1 factorial.
Yes, sir.
Something like this. Okay. So xn plus 1, that means if this is n, then your R2x would be what? Let me write it on the next page. R2x. So for 2, it will become 3. And derivative of ex is ec, right? And x cube by 3 factorial. For some c belongs to 0 to x. That's how we write it. Okay. That's how we write it.
Yes, sir.
Yes,
Now,
sir.
you know that your maximum value of x is less than 0.01. Huh? Even your c cannot go beyond this. C is something like between 0 and x. So that means your error cannot be more than this quantity. Which quantity? I'll write it as e raised to power point. Is it a 0.01 or 0.1? Let me check this. It's there on.
Sir, it's 0.1.
It's 0.1. Okay, I mean, you can do it as 0.01 as well, but anyways, I'll do it 0.1 in order to make everything in apple pie order. Okay, so let's 0.1. So e raised to power 0.1, 0.1 raised to power 3, and upon 3 factorial. You just count it, and then you get the answer for this. Okay, so just calculate it. What is that? Can you calculate it?
Yes, sir.
Yeah. Just calculate it and tell me.
Sir,
Yes.
so on what basis we termed it as R2X?
मुझे तुम्हारी कोई आवाज नहीं समझ आ रही है कि क्या बोल पा रहे हो तुम.
Sir, I am asking on what basis we have termed it as R2X?
R2x. That's what I'm saying. See, you have a Taylor polynomial P2n, right?
Yes, sir.
How you write the function? You write the function as Pnx plus Rnx, right?
Yes, sir.
So what is your Pnx? P2x?
1 plus x square by
Second
2
order.
factorial.
Second
Yes,
order, right? So
Yes,
that's
sir.
why the left would be R2x,
Okay, sir. Got it.
right?
Yeah, sir. Got it.
Okay. So can you calculate this for me?
0.00018.
Yes. This is coming out to be 0.001841195. I have also calculated. Okay. So something like this. Right?
Yes.
So is
Yes,
it
sir.
okay?
Yes,
So
sir.
are you getting this? Yes, sir. Are you getting this? Now, can you tell me what is the difference that where I'm using the alternating estimation theorem and where I'm using the remainder estimation theorem?
When we know how many terms are there in the.
Yeah, that is one way. But anything else?
In expansions, no.
No. Something more?
Sir, when x is small,
No. X is small. That is requirement of both the cases.
Sir, when some terms are not missing.
That is another point, but I want to ask you something else. I want you to tell me a very good reason. These are few reasons, of course, but this is not the the ultimate reason. Ultimate reason is lying within the series. You can directly see the series and you can tell me.
When no term in the series is zero.
Of course, right? So if your series is not alternating, see this thing. Your series is not alternating. How can you apply the test of alternating estimation theorem? Okay,
Yes, sir.
you got my point.
Yes, sir. Yes.
Yes, sir.
You got my point. So everything which is which is done, it has a sort of its own importance and its own weaknesses, and of course strengths as well, right? So what I'm trying to say is, so let's say so note alternating estimation theorem, alternating series estimation theorem. Yeah, okay. Theorem is applicable only when the series is alternating. So that is one limitation of this. Okay, ये limitation होगी ना इसकी.
Yes,
This
sir.
is applicable only when this thing will happen. Okay, otherwise it will not be applicable, as we have seen in this case, question number 23, right? Anna, so remainder estimation theorem, or I'll simply call it as remainder theorem, right? So let me call it as remainder estimation theorem. Is applicable even in non-alternating series, right? Even when series is not alternating, right? Is it fine? Are you getting this? But
Yes, sir.
but it should be applied with little more care, right? होनी चाहिए ना थोड़ी सी. Why little more care? Why little more care? Can anybody comment on this?
The series can be written in different forms.
Yes, that R4 and R3 factor can be there in the can be there, right? So the kind of example we've done. That's why. So same is question number 25. You should do it. Question number 25 to 28, right? You can do it. That's it.
सर जो आपने ये इस लेक्चर का एग्जांपल फर्स्ट जो करवाया था उसमें रिमाइंडर एस्टिमेशन थ्योरम का जो पार्ट करवाया.
हाँ. मैंने एक्चुअली वो ये बताने के लिए बताया है कि लगाने को एक जगह पे दोनों चीजें भी लगाई जा सकती हैं, लेकिन अगर तुम रिमाइंडर एस्टिमेशन थ्योरम लगा रहे हो तो तुम्हें R3 की बजाय R4 यूज करना पड़ेगा, क्योंकि एक्चुअली वो R4 की रिप्रेजेंटेशन बन चुकी है. ठीक है, ये बताने के लिए मैंने वो एग्जांपल करवाई है.
सर तो पर उसमें जीरोस तो और भी बीच में
नहीं,
आ रहे हैं.
और जीरो नहीं, वो और जीरोस नहीं बनेगी, क्योंकि अगर तुम 4 के बाद जाओगे तो वो फिफ्थ ऑर्डर इंक्लूड कर लेगा. तो फिफ्थ ऑर्डर इंक्लूड करने पे उसे R6 कहना पड़ेगा ना. तो R6 हम उसे कह नहीं सकते. तो वहां पॉसिबल दो ही चॉइसेस बनती हैं. ठीक है, एक R3 की और एक R4 की, और जो कि हमें R4 लेनी पड़ेगी. That's what I've explained, right? अगर तुम यहाँ पे एक टर्म और इंक्लूड कर लोगे, let me go to that thing. Yes. So yes, if you see, यहां तक तो तुमने यहाँ पे लिख लिया कि ये तुम्हारा है, ये 0 आ गया, लेकिन इसके बाद अगर तुम 5वें पे जाओगे तो वो R4, वो फिर यहाँ पे भी तो 5वीं टर्म लिखनी पड़ेगी ना इस साइड पे, ये दोनों बराबर होंगी नहीं।
यस सर।
जो कि हमें गिवन नहीं है, हमें तो यहाँ तक ही गिवन है। सो देयर आर ओनली 2 पॉसिबल केसेस, राइट? Not more than 2. That's what I'm saying.
ओके सर।